Hello, my name is Max Kim, and this is my arc length project. So for my project, I chose a walking path, in Old Japan. And the reason why this path is relevant to me is because I live in the area, and I usually walk my dog along this path, usually further, but this is one of like the main uh, parts of like my dog walking experience. And yeah, so I just wanted to use this for my project. So the first thing I did is, as I saw in the tutorials, I rotated this path um, a couple degrees to make this street, Fred Street, the horizontal x-axis that I would be basing my coordinates off of. And I used that, and I put that in Desmos, as you can see here. I plotted all of these points um, using the dimensions in feet from the measure tool, and then so these are actually the feet. These are actually the units, and I used a bunch of points in order to capture like both the straight lines and like the curves, like the elbows of my path. And in the end, I used what is it? I used my arc length formula to calculate the arc length of this bend right here. Oh no, actually not this one. It's actually this bend right here. I circled the wrong thing. Let me move. Yeah. So I, sorry. I calculated the arc length of this bend here. So yeah. So now I can move on to my calculations. So the first thing I did is I inputted all those points that I initially put into Desmos. I put them into the graph app. So if we could see, yeah, here are all the points. Again, they're just put in into the graph app, and then from there I formulated a eighth power polynomial. So as my regression. So and that I felt like that captured a lot of the points super accurately, especially around like this bend. Because the higher you go, the more complex the polynomial become, and I didn't want it to become too overcrowded. So here is the final functions formula for my regression. It's it's an eighth power. And then from there, we just take the derivative, right, in our arc length formula that we learned about. So we take the derivative and then we use it in this formula. And if you look at the points from the start of the elbow, start of this curve to the end, it goes from x value 1522 to 615, 1615, which you can see here, 1522 to 1615. That's when it starts rising around here. It goes from 461 to 477 to 501 to 501. So I captured that part of the curve there, which is reflected here. So like that part. So I use those for my two bounds, and then I simply input this into a calculator with the basic arc length formula. So 1 plus the derivative of f. So that came out to this after I calculated, and then squared, and then take the square root of that, and then calculate the integral. So the final arc length of my segment was 166.7 feet for this section. Thank you.